Hello, welcome to the second video for chapter 4. We're talking about discrete probability distributions, where you have a set number of outcomes that take a set of outcomes that have numbers as their values, and you cannot have any outcome that isn't in your list of values. So a reminder, the mean of a discrete random variable or discrete probability distribution is written as mu, or the expected value of x. These three things mean the same: the mean, the mu, and the expected value of x. Find the expected value of x by multiplying each possible value by its respective probability, then adding up all those multiplications. We call those products, adding up all those products. The other question we might ask is, how spread out would we expect our data to be if we collected a large number of trials? This is asking about the variance of the probability distribution, the probability distribution. So just like with the expected value, we can calculate the variance of the probability distribution using mathematics, in fact, by extending the table. So in case it wasn't clear from the last video, pro tip, using a table is super helpful for understanding a discrete probability distribution. So let's find the variance of the first example I gave you, which was flipping a coin, getting a heads or a tails. So our outcome was you could get a heads or tails. The value of the outcome, if you got a heads, you won $10. Fantastic. If you got a tails, you didn't win anything. Oh well. Since you're flipping a coin, the probability is 0.5 for each, and the value times the probability for heads is $5 and for tails is $0. And that told us that the expected value of that probability distribution was 5 plus 0, which is $5. To find the variance, if you think back to the previous video, this took a lot of steps when working with data. It takes a lot of steps when working with a discrete probability distribution as well. But the steps are fairly straightforward. So I'm going to take this table and I'm going to expand it some more. Okay. So in order to find the variance, the first thing you need to have is the value minus the expected value of the whole distribution. So our value of the outcome is $10. The expected value was $5. So it's $10 minus $5. And I'm going to do that for each of the possible outcomes. Here it's going to be $0 minus $5. So on the top, it's going to be 5, and on the bottom, it's going to be negative 5. Now, if you remember from finding the variance or standard deviation of a set of data, after we found those distances, we squared them. So we're going to do the same thing here. We're going to square all those distances. So we're going to take 5 squared, which is 25, and we're going to take -5 squared, which is also 25. And then the variance is the sum of the squared distances. Oh, no, not quite. Sorry, missed a step. All right, we have to do one more step, which is we take all these values, call these the sum of squared distances. I need to use that abbreviation. The last thing we're going to do is we're going to take the sum of the squared differences times each of their probabilities. So here we have 25, and the corresponding probability is 0.5. So that's 12.5. And here we have 25, and its corresponding probability is 0.5, which is also 12.5. And now we're ready for the variance. Variance of a discrete probability distribution is the sum of the SSD times probabilities. So in this case, it's 12.5 plus 12.5, which is exactly equal to 25. The notation for that, I usually write VAR. And just as with data, we can also look at the standard deviation, which is a square root of the variance, which in this case is square root of 25, which is 5. Now, it's not a coincidence that we're seeing the number 5 pop up so often in this example. It's because we have nice even probabilities. We have nice round numbers for the money. Our interpretation, the standard deviation of this probability distribution says that on average, we would expect to win $5, the expected value of X, but we would not be surprised if we won $10, which is the expected value of X plus the standard deviation, or won $0, which is the expected value of X minus the standard deviation. Now, the standard deviation tells us roughly how much spread we would expect when collecting data. And we would expect to get pretty frequently $5 above the average or $5 below the average. And that matches really nicely with our actual table. So I'm going to do another example. I'm going to do this example here where we're rolling a die, and let's calculate the variance and the standard deviation. Rolling a die, getting 1, 2, 3, 4, 5, or 6, winning these amounts of money with these probabilities. We already found that our expected value was $2.166. So let me add in our 3 extra columns. Okay, first we're going to do the value minus the expected value. So we're going to do 0.833 minus 2.166 minus 0.5. Oh, no, I'm sorry. I got that wrong. Not the value times the probability. It's just the value. So it's 5 minus 2.166, and negative 3 minus 2.166. Let me use Google Drive here to help me a little bit. It's not helping anymore. That's too bad. Okay, let me use R. 2.834. 2.833. Now this is negative 5.166, which we're going to repeat a bunch of times. And then 20 minus 2.166 is going to be 17.833. And now we're going to square all of these, value minus expected values, which we called our squared distances. I'm sorry, it's not sum of squared. I'm going to call it SQD. SQD, square of the differences. So 2.833 squared, which is 8.026. And negative 5.166 squared is 26.69. And 17.833 squared is 318, more or less. Okay. And the last step before we add it all up is to multiply each of those squared differences by their probabilities. So 8.026 times 0.1667 equals 1.34, about. And 26.69 times 0.1667 is 4.45. That here. And then 318.16 times 0.1667 equals 53. So our variance is going to be 1.34 plus 4.45 a bunch of different times plus 53, which equals 72.14. If you remember, when we're talking about the variance of a data set, I told you that it's not really to scale with the data set. It's the same thing here. 72 as a variance is not at all to scale with the different possible values. But once we do the standard deviation, which is the square root of 72.14, about 8.5. I'm going to write 8.5. That is nicely on scale with these values. So what this is saying is if we ran this trial a number of times, we would expect to win about $2.16, but we wouldn't be surprised if we won up to around $16 or as low as losing $6. Notice that this is imprecise. We aren't ever going to win exactly $2.16. You can't. The only values you could possibly win are 5, lose 3, or win 20. And although mathematically speaking, we wouldn't be surprised if we lost $6, right? That's the expected value minus the standard deviation. This couldn't actually happen for real. The most we could lose is $3. So when you calculate the variance and the standard deviation of a discrete probability distribution, they give you an idea for your range of possible outcomes, but it's not going to be precise and it's not going to be exact. And so I want you to keep that in mind. All right, this concludes our video here. You will be asked to do these calculations on your homework. I'm not going to ask you to do them by hand on a quiz or even a lab. There are built-in things you can use in R to calculate these, but they're a little clumsy, so I'm not going to be teaching them in this class. You'll get a chance to do it once or twice by hand. And again, the key is to use a table to keep everything organized and to just step it across one step at a time. I'm going to run through it one more time, how to build the whole table. So first list your outcomes. Here's the roll on the die. List the value associated with the outcomes and the probability of each outcome. If you want to find the expected value, which is the same as the mean or mu, multiply your value by your probability and then add all of those up. If you have negative values, you're going to have some negative terms there, and that's okay. You add all of those up, and when you sum the value times probabilities, you get your expected value. If you want to go another step and find the variance, then you take your value and you subtract your expected value, $5 minus 2.166. So you get your value minus your expected value. Then you square that to get your squared differences. Then you multiply each squared difference by its probability. And then you add all those up to get the variance. And to get the standard deviation, you just take the square root of the variance. All right, one more video to come for this chapter, and I'm going to stop this recording now.